Okay, we did 1 through 4. 1 through 5 all. Number 1 is about 37,734,070. No, I read that wrong. Excuse me. About $37,734.73. Number 2 is about $620.46. 3A is 2,200 times 0.98 to the T. 3B is about 1,624. 4, the initial is 270. Rate of change is 65% per week. If this growth rate continues, then the number of likes will continue to increase, exceeding 100,000 in 12 weeks. 5A, y equals 550 times 1.03 to the T. And 5B is about 964. Okay. We could do 1, except it looks to me like, no, yeah, 1 and 5 you should have been able to do. Now we can do it, and maybe 4, but 1 and 5 fit, but the other ones, I don't know that they quite fit the examples that we've done so far. So we're going to have to make sure we get all the correct formulas today and get that all ironed out. And then we'll assign some more practice for Tuesday, and then we'll have a test on Thursday.
So 1 and 5 are the good ones?
Number 1 and number 5 go with example 2, which we did one like example 1, which is the same exponential growth equation as the other. So that fits the same equation that we've been doing.
You said the test was on not this Thursday, or not Tuesday, but Thursday?
Yes.
Okay.
The test is a week from today.
Okay. So we're doing another like 7-7?
No, we're doing the rest of 7-6. Okay. Yeah, well, so we can do number 1. That's fine. And then we may continue with the lesson and then kind of see what we do from there. So number 1 from page 433, Miss Acosta received a job as a teacher with a starting salary of $34,000. According to her contract, she will receive a 1.5% increase in her salary every year. How much will Ms. Acosta earn in 7 years? Okay, so it's exponential growth. It's getting bigger. She's getting paid more and more each year, right? So what does the formula look like?
Y equals A parentheses plus, no, I mean 1 times R.
Not times.
Plus R.
Plus R.
Parentheses over X. No, that.
Great. So what is this number? That's the starting amount. What is this number? R. So we need to convert this to a decimal instead of a percent. So what do we need to do? Yeah, you put it over 100, which is divided by 100, which we just move it. Yes. Move the decimal place. 0.015. What is this? T. Great. So y equals 34,000 times 1 plus the rate to the 7. Now what? We gotta simplify all that stuff. Gotta like do the math. Mm-hmm.
I was confused on this because on the practice one we wrote down words instead of doing
Hmm?
in the first one, in our practice one on Tuesday, we wrote down words. So I
Right.
didn't know what we had to go.
Okay. Now what? No, you can't. You can't multiply because multiplication doesn't come next in the order of operations. What comes next? The exponent. So we got to do 1.015 to the 7. And then multiply that times 3,400. Yes, that's this to the 7? Yeah, so then push times 34,000. 37,735 is about what she will be making. Okay, let's kind of continue on with the lesson, and we'll see what we do with some problems and go from there. You have like 5,000 for some reason?
5 instead of 3, I don't know. And it's, I put like, in 7 years you have this much. Because
Right, yes, and you could write it all out as like, in 7 years she'll be making this much, would be a great way to write the answer. Absolutely. Okay, so let's get a couple more formulas and do a couple more problems or so. Let's see what happens from there. No, we cannot do 3, but because have you been listening to any of the words I'm just saying? We're gonna go back to the lesson and then we can hit some of those if we want to. Okay, so we need an equation for compound interest. I was talking about this equation the other day, so now you get to have it. And it's only a little bit different than the exponential growth equation, only just a little. Okay? The equation for compound interest is A equals P times 1 plus R over N to the N T. Okay? So it's really similar, and most of it's exactly the same. Exactly the same as the exponential growth equation. Okay? So P is the principal. What's up? Which is your starting amount. It's the same as before. A is the same as before. It's the amount earned after T years. Now this one does have to be in years. Exponential growth can be in months or whatever else, but this one has to be in years, and it has to be years a lot because of the n variable. R is the same thing. What is R? What? Oh, rate, yeah. It's the interest rate. Same thing, right? And T is time in years. N, this N and this N are the same thing, is the number of times it is compounded annually. So if it said it's compounded monthly, what would N be? If it said that this account is compounded monthly, what would N be in that problem? How many months are there? 12. Great, look, you did it. What if it said daily? 365. What if it said quarterly? 4 times. 4 quarters of the year. Great. Most of them are pretty straightforward. I'm just gonna. You could say daily. You could say quarterly. You could say weekly. If it was weekly, what would the number be?
7.
How many weeks are there in a year? 52. Now, the only one that you might have to think about is semi-annually. If it said semi-annually, what would that mean? What number would it be? No.
6?
That's as good a guess as any, but no, 2. Semi-annually is 2. That means 2. Right? Most of them are pretty straightforward. Okay, let's do an example. We're going to do guided practice 3 on page 431. Determine the amount of investment if $300 is invested at an interest rate of 3.5% compounded monthly for 22 years. So what about this particular problem tells us we're going to use the equation we just wrote instead of the regular exponential growth equation? Yeah, the compounded monthly part. If it didn't say compounded monthly, we'd just use the regular exponential growth and move on with our life, right? Easy peasy, just like that one we did a minute ago, right? So we find our variables. We've got this equation.
What page?
431.
Okay. So that 300, what variable is that?
Amount.
It's the amount at the beginning, right? It's the principal. What is that 3.5%? It's the rate. What do we need to do with that number? Yeah, turn it into a decimal. So what would it be as a decimal? 0.035, that's right. Okay, and then N is 12, that's true. And then what's that, 22? Okay. It's already in years, we don't have to do any conversion. If the problem said this and this happened, this and this happened, and how much would you have in half a year? Or how much would you? No, I gave away the punchline. I apologize. If it said 6 months, you'd have to turn that into 0.5 because in this equation, t has to be in years.
Which is half a year.
Right. That was all the things I said. Yes. Okay. So we just shove stuff in to the equation. Yes, I don't know why I'm writing that. That don't make no sense.
Is it supposed to be 360?
I don't know. What was it? What did I actually read? 300. I did write 300, and then for some reason I wrote 350. I probably was seeing that 5, and my brain got confused. Okay, so now what would we do?
We would probably multiply the
Sure. 12 times 22 is what?
264.
Now what would we do? Divide. That sounds like a great idea. What's 0.035 divided by 12?
0.0029.
Now what? Now, on your calculator, instead of pushing 1 plus 0.0029, just put plus 1, right? Because then it keeps all whatever things, and you're not rounding ugly and weird, right?
1.0029.
Yes. I mean, that's obvious. You can do that without a calculator, but you've got the correct number in your calculator for the next step. What's the next thing you're going to do? Exponent. Yeah, so you push to the 264, right, on your calculator. No, you should have this number sitting in your calculator right now.
2.146.
Right? And then you just push times 300. And then we don't really have to round anything until the very end.
It's 2.1147.
It doesn't matter because you're just going to push times 300. So do that, and then what's the... $644.47. Make sense? Now, depending on where you round it or whatever, you might get it just a little bit more or a little bit less on your calculations. Like the book says it's about $647.20. But that's just because of a difference in when you rounded. Okay? One more equation today. Exponential decay. This one we don't really have to label all the things. This one, if I told you to write it, you could probably guess what it was going to be. What do you think the equation for exponential decay is going to be as compared to exponential growth? Same thing with negative. Yeah, that's exactly right. A equals 1 minus r to the t. Did you cheat and look at the book? What are some things in the world that have exponential decay?
Life.
No, life has linear decay. Radioactive elements have exponential decay, where they decay a whole lot at first.
Anything that you can't remake.
Anything that you can't remake.
If you have something that you can't.
So what we're talking about is, so you're look, just for the sake of clarity, what we're doing. So exponential decay would be like you have something here, and after 1 year, it kills off this much. After 2 years, it kills off this much. Then after 3 years, it kills off this much, and then this much, and then this much, and this much, and this much, and this much, and this much. So where you do a lot and then a little. So that when you graph exponential decay, we actually know this is from doing this the other day, it looks like this. Big old drop, and then you're losing less and less and less and less and less. Radioactive material loses a lot of energy really fast, and then it slowly decays over time. Okay, let's do an example with exponential decay. Let's do guided practice 4. No, I don't want to do that. Just kidding. LOL, JK. How about guided practice 5 on page 432? The population of Campbell County, Kentucky, has been decreasing at an average rate of about 3% per year. Exponential decay if you're decreasing by a percentage each time, then it's exponential decay. But if you're decreasing by a fixed number, it's linear. Right? So 3% per year. In 2010, its population was 88,647. Write an equation to represent the population since 2010. If the trend continues, predict the population in 2020. So, this is decay. We know it's decay because that's the part of the lesson. But what actually tells us that it's exponential decay in this problem? It's decreasing, right? So, what equation are we going to use? The one we just wrote. Y equals A times 1 minus R to the T, right? So we've got some numbers. We've got a 0.3%. What is that?
Rate.
It's the rate. What do we got to do with it? 0.003. And then, well, 2010 will help give us the time. Yeah, we won't need that until we do kind of part A first, right? So, what is the 88,647? A, it's the amount at the beginning, right? 88,647. So to do the first part, it says write an equation to represent the population decline. So we just shove these things in there. So y equals 88,647 times 1 minus 0.003 to the t. We need to clean that just a little bit before we can circle that and move on from part A of this problem. What do we need to do? Yeah, we need to do that subtraction, right? So what is 1 minus 0.003? You probably don't actually need your calculator, but that's fine. 997 to the t. So we would circle that for part A of this problem. That's finished, right? It didn't write it as A and B, but there is because it asks for two different things. So that's part A, right? Then it says, if the trend continues, predict the population of 2020. So What are we going to do now?
Replace the T with 10.
That's right. T would be 10 years. Because from 2010 to 2020 is 10 years. So we just, what?
Nothing. I said we spelled rat.
Did we? Oh, we did. Look at that. So cute. 1,647 times 0.997 to the 10. Okay. So what is 0.997 to the 10?
0.970177696.
Right? So what would you do now? Push times and then that number, right?
And times that.
86,023.20.
About, we can't have half a person. About 86,000. This says 23. What did y'all get?
86,23.
Okay, 86,023 people.
Technically, if someone has no legs or no arms, that's technically about half.
No, because a person is not a body. Make sense? Easy peasy? Great. Your homework, which you may start now, is page 433, numbers 6 through 18, all. Let's do it on Tuesday. Then we have a test on Thursday.
I'll just do it all now.
Wait, 73? What is that 7 or 2? Or about 3?
Well, look at the top of the page at what lesson we're on, and you got this.
So wait,
Because 473 is not in this unit. There also aren't any problems on page 473, except for examples.
Still lesson 7-6.
It is lesson 7.6.
Point 7, point 5.
Sure, part 2.